So now we're going to look at the last derivative technique that we're going to use. It's called implicit differentiation. So there's a lot of times where when we're calculating a derivative, solving for y is not really practical to take a derivative. Like, for example, look at this equation. I can't simply solve for y, or at least the equation for the solution for y would be pretty painful to work out. And so what we're going to do is we're going to simply take the derivative of both sides of the equations, because a fundamental part of algebra and just logic in general is that I can do whatever I do to one side of the equation, I can simply do to the other side of the equation, and they'll still retain their equality. So I'm going to take the derivative of this side. Well, the derivative of x to the fourth is 4x cubed by power rule. The derivative of this, you want to think of this as y as some function of x. And I'm squaring it. So when I take the derivative of this, it's 2y. But by by power rule, it's 2y to the first power, so I don't write the 1. But by chain rule, I got to take the derivative of this, which I write as y prime. You could write as dy dx, it doesn't really matter. Plus the derivative of y is y prime, and the derivative of 7 is 0. So I just went through and took the derivative of each piece separately. And now what I can do is I can group the y primes together. So this is 4x cubed plus 2y. Whoops. Let me factor out a y prime over here. Times 2y plus 1 is equal to 0. I can bring everything without a y prime to this side. So y prime 2y plus 1 is equal to negative 4x cubed. And then divide by this, and I get y prime is equal to negative 4x cubed over 2y plus 1. Okay. Let's try this one. Cosine of x. Derivative of cosine of x is negative sine of x. The derivative of sine of y is cosine of y. But because the inside is not x, by chain rule, I multiply by y prime, or the derivative of y. The derivative of 1 is 0. And so then I can rearrange and solve for y prime. So I'll bring the sine x to the other side. So cosine of y prime is equal to sine of x. And so y prime is equal to sine x over cosine of y. Now note that when you do implicit differentiation, the solution will contain both x and y, and that's normal to do. Okay. So this one I could do quotient rule, or I could rearrange this to say y is equal to 10x, and so y prime is equal to 10. So that's how I would do this particular problem. But as a practice for doing implicit differentiation, I'm not going to rearrange it. I just take the derivative of this, and I'm going to do quotient rule. I'm going to do x bottom times the derivative of the top minus the top times the derivative of the bottom divided by the bottom squared. And the derivative of 10 is 0. Okay, and then really this part has to be 0. So x y prime minus y has to equal 0. I can or multiply through by x squared, if you want to think of it that way. And so x y prime is equal to y, and so y prime is equal to y over x. And you might say, like, well, that's not equal to 10, but y over x is equal to 10. Right? So it's the same thing. Thanks for watching. If you're looking for more examples, go to my website. In there, I have free access to over 400 calculus questions that I solve and I show you step by step. So if you're interested in seeing more, please check out my website.